Okay, thought I'd go over 2014, so just do section one just now and see how much I can get done. Right, so first one, it's a wee bit different way of asking to use complement, but it actually turns out simpler to work out. So they're basically this time, instead of giving you a minus decimal number and asking what the binary is for it, they're doing doing opposite. So they're giving you what the byte is and what would that be if you converted it back to your minus decimal number. So all you're doing here is you just rewrite the number they're wanting you to convert. And so, in fact, I'll just use another pen. Let's put your wee number system, okay? So it goes up in 2 since it's binary. 32, 64, 1 to 8. Now, you've done these before, but you've converted it from binary into decimal, and it's come up with a positive integer. So you'd have said, well, that's 1 to 8. You'd then plus 64, plus 8, plus 4, plus 2. You've added these up and it'll come up with a number. Oh, it's different. It has to be a minus number, so you just put a minus there. So it's minus 1 to 8 plus 64 plus 8 plus 4 plus 2. And when you put that in your calculator, that's minus 50. If you wanted to prove it, you could then, and you don't need to do this in exam, but you could then get minus 50 and then work your 2's complement with that. So make that positive 50, flip it, add 1, and you'd actually end up with this. Right, so that's your question 1 done. Now if you look at question 2, and again you'll start seeing they're asking quite often similar questions. So they're just saying ASCII code, Unicode, what's the advantage of Unicode? Just say represent more characters. So try and use the word represent, because remember it's in the topic data representation, right? But that's essentially what you have there. You then go question 3, and that's obviously just a line. And they're just saying it's a vector graphic. So think about the line. If you had to redraw that line without seeing it, you would need to know the coordinates of x, y coordinates of either end. You would need to know the line thickness, the line colour, and that's essentially they're just asking for 2 attributes. So all these things I've mentioned are attributes. So again, this list might be not the one that you have, but you might have starts xy with end xy, so that's where the line starts, that's where the line finishes. You have, you get to say, some of the obvious ones are the easiest to remember: line thickness and line colour. Okay, so xy coordinates, start and of end, depends in what way you want to think of it, where it's starting and where it's finishing, right? But there's, if you look at the marking scheme, you'll find there's quite a few different alternatives. Right, so question 4 is you've got a register and you've got instructions held in it. What else do you have? So if I just put question 4 down there, if I just say, right, you've got a register, so these temporarily hold data within the processor, right? And they've already told you that you have, was it an address or instruction? Right, so I've already given you another one, right? So it can hold an instruction, can hold an address of a piece of memory that it might be taking instruction from or placing instruction, and it can hold data, so it might be a value taken in from the user, right? So that's essentially what registers can hold. If you then look at, so they're looking back at memory, so what about memory? If you think about memories just being a row of houses, all got their own address, the post person knows where to deliver, and it's the same case. So you've got your memory there, and they're all uniquely identified. Okay, I won't do any more than this. Right, so they've got their own addresses, and that is known as addressability. Yeah, so that obviously links in with this, right? So, but that's known as addressability. Right, next question. Talking about solid state, no moving parts, so they're a bus, so they've already told you one of the answers. Describe 2 other reasons. Solid state, right, no moving parts means it's robust, it also means it consumes less power, so there's not any power spinning this disk around. Also a lot smaller as well. Faster read-write speed, so there's quite a few to choose from, so they're just asking you for the two. So what we have is consumes less power. And we can also say fast read-write speeds. Okay, so faster read, or you could say faster access times, faster read-write speed. Right, and again you can always have a wee look at the marking scheme and see the alternatives. Now, where we've gone wrong there is consumes less power. Right, you could also just basically say no moving parts. Right, so this is where I didn't read the question right. It actually says describe. Right, so I've just named them, so I've actually lost the mark. Right, so you'd say describe. Right, so no moving parts. No faster read-write speed than magnetic device. Okay, so your hard drive in your computer, if it's not solid state drive you've got, it'd be magnetic hard drive. Right, question 7. Looked at these quite a lot and they're just talking about, well, got an interface and it's converting from analog to digital. What's the name of this function? And that is data format conversion. Right, so data format conversion is your analog to digital, your digital to analog. You can also have things like your serial to parallel. Okay, these all come within data format conversion. Right, so that's question 7. Right, and I'll squeeze this on that page. Right, what's one function of a web server? Right, well, the main one is just to store web pages. Right, stores web pages. So this is a past paper, you all got handed this out. If you don't have it, remember it's 2014, just go into the SQA site. Okay, so that's us in question 8. Other answers you could have there, you're talking about, well, allows you to host websites, so you can have your own website up and running. Also allows you to access web pages, right? But that's the main one, and I would hope it's probably the easiest one to actually think of. Right, so describe the function of the bootstrap loader. Right, so the function of bootstrap loader. Right, so I'll just have this wee piece of paper. Right, so essentially it's in memory and it just loads up the rest of the operating system in your hard drive. Okay, so essentially I have to say question 9, I'll just say locate and load operating system from hard drive into memory. That's its wee purpose in life. Okay, so it's located in memory, small part of the operating system. As soon as it's on, it then gets the rest of the operating system from your hard drive and puts it into memory. Okay, and here we go, and we have question type of software. System software, what's a disk editor? Okay, so that system software allows you to add more functionality onto your operating system. And an example is we just call it utility software. So you've got your antivirus, you've got your disk editor, you've got your defragmenter, so they all help the operating system in running your computer. Right, doing this quite quickly, but we'll see how much we get done. Okay, so state type of virus. So it's a type of virus that's infected with computers infected with a virus that is activated within a general purpose package. So this will be known as a a macro virus. Okay, so this is when it's activated within it. So it's actually embedded within an application. So it might be an Excel spreadsheet. Okay, and then you run your application, and the macro virus, if you're running a macro within it, the document, that's when that's activated. Okay. And if you look at B, describe the checksum. Okay, so first one, macro virus, and then the checksum. And what actually happens is, so the initial checksum is performed in the file. Okay, and this is before infection. So essentially look at the contents of the file and perform a wee checksum on it before, and a second one is actually done it after it's been opened. Okay, so a second checksum is performed when a file is open. Sorry for my rush writing. Okay, and if there's actually any differences before and after, then you know something's happened. Okay, so differences indicate a virus. So I suppose it's like leaving a jar of sweets in a room. Check it before somebody's gone in, check it after somebody's gone in, and if there's some missing, you know something's gone wrong. Okay, so they look at the file before infection, perform a wee checksum on it. They then look at it when after you're suspected there's an infection, and if there's a difference, there's a good chance there's a virus. So that's your checksum. Okay. We have then number 12, a very common question. What's a example? Right, use an example to explain the production of the software specification as an iterative process. So basically, your iterative process is when you have to revisit a previous process in light of new information. Okay. So just use this wee bit there. Right, so what could happen is, so you're doing a software specification, okay, so you might be maybe interviewing between analyst and client, and that's just to basically maybe to clarify the exact requirements. So you might have to go back to them a few times just to make sure that you're happy with the exact requirements. You might have found out new information that you didn't know when you actually created your software specification, so you might have to go back and feedback into that, discuss it with the client again. Okay, so it's not always plain sailing in terms of you get it all finished, put a dot at it, sign it off, and then go into the design stage. You might be in design and realise, alright, you found out some information that needs to be fed back into this software specification. Okay, so it can be something that rolls on, right? And question 13, an app has been created, and here's a top level algorithm. Okay, so this is top down design, right? Top level algorithm, and they're just basically saying, well, what type of design is that? And hopefully you'll be able to say, well, that's pseudocode. Right, so this is pseudocode. And it then just asks you, well, state one parameter and its data flow which is required at step 2. Right, so step 2 is calculating your interest. So what you need to do is you need to, again I'll do it so you can actually see it, that'd be handy. Right, so you're going to have to calculate the interest, you actually need to know the amount. Okay, you need to know the rate as well, so these two get fed back into it, and what comes out is your interest. So your in parameter is amount, So what generally is going out of here is going into the other one. Another in parameter is rate, and your out parameter is just your interest. Right, and that's that. And very last one, question 14. Another sheet of paper. Right, so question 14 here. During the implementation stage, 2 reasons why module libraries improve development time. Okay, so obviously they're not pre-written. Right, so we can say question 14. The code's pre-written, and the one that's pretty much goes on to the end of that, if you can actually see it, is it's pre-tested as well. You could go on and say it's pre-documented, right? So modules, they're all ready written for you. They're already tested, already documented, and that's why a lot of folk like them, right? Right, thought that was the end of section 1. That turns out it's not. Right, so you've got question 15 here, right? These ones are not too bad. So they're basically asking you, right, if a program does not make unnecessary use of system resources such as RAM, what is that? Well, that is you looking at the efficiency. And again, hopefully you've got these in front of you because I'm going through it quite quick. The program will run on another computer system without much change, essentially, right? And that means portability. Okay, that was B. Right, so efficiency, it doesn't overuse the resources or to excess, and portability, right? We then have, what's one benefit of using macros? So it's another wee macro thing. So what you've got there, there's quite a lot of them actually, right? But one of the main ones, this allows complex actions. Actions to be triggered. Okay, just by one button. Okay, I mean it allows you to maybe change the graphical user interface as well. You can customize it. It makes things more flexible as well, makes the application more flexible. So you can customize not just the user interface, but what you can do with the application. So there's quite a lot. Question 17, what we have is declaring a 1D array. Program must be given a name. What other 2 items should be specified? Okay, so you need to actually specify the size of the array and the data type. Okay, so you need to specify size of array and data type. Alright, so it could be, you had dim age 99, so 100 ages, and then just as integer. Right, so that's specifying the size, that's specifying the data type, and that should be a T. And this is the last one. Question 18, I suppose you'd want to actually see the question. Software development and independent test group during the test, and they're made up of people that are not part of the development company. State 2 reasons why the software development company uses an independent test group. Right, so I'll let you have a wee look at that. So it's a very common question to get. Well, basically, they are more likely to employ a wide range of testing, more likely to employ a wider range of testing. Okay, so this is their professional job, so they've even got tools and other pieces of software to test the software. Wider range of testing. Okay, they're not going to start signing off projects just to make sure they meet a deadline. Okay, so we will not sign off project to make a deadline. And quite often, I mean, if you read an essay you've written, you might not spot an error, but if somebody else does it, then they spot it. So they're more likely to actually see some of these errors that the programmers missed. But that is 20 minutes of section 2. Remember, 2.5 hours long, and it's 120 marks. Right? So you'll be able to work out how many minutes per mark, right? But that's section 1 done for you.